Hello everyone, welcome back to another physics lesson. I'm Physics Michael, and today we are going to explore the topic of motion under gravity. We will begin by understanding the acceleration of free fall, and then we will apply the equations of motion to objects that are flying through the air. Whether they are falling from rest, slowing down, or slowing up, let's dive right in. When an object is in free fall, that means it's falling without air resistance, or we can ignore the air resistance completely. In that case, the only force acting on the object is gravity. If you make a multi-flash photo of the ball dropping through the air, you will see the spaces between the ball's positions getting larger. That's because gravity causes the ball to accelerate downwards. This constant acceleration is called the acceleration of free fall, or just the acceleration due to gravity. On Earth's surface, it has a value of 9.81 meters per second squared, and it always acts vertically downward. We use the letter g to represent the acceleration due to gravity, so we can rewrite the Seward equations by replacing the letter a with g. Let's start with an object that is dropped from rest. That means the initial velocity is 0. So using the motion equations, we have final velocity equals g times time. Displacement equals 1/2 of final velocity times time t. Displacement equals 1/2 of g times time t squared. And final velocity squared equals 2 times g times height. These are motion equations for objects in free fall from rest. Now let's try applying these equations to a real situation. Imagine an apple falls from a height of 4.9 meters. We will ignore air resistance. We want to find two things. One, what is the velocity just before it hits the ground? And two, how long does it take to reach the ground? We are given initial velocity equals 0. Acceleration equals positive 9.81 meters per second squared. Displacement equals 4.9 meters downward. We take that as positive since we are veering downward. We use the equation. Final velocity squared equals 2 times g times h, and final velocity equals g times t. After solving, we find that the final velocity is about 9.8 meters per second, and the apple hits the ground in about 1 second. Now, let's look at what happens when we're throwing something downwards instead of just dropping it. A ball is thrown downward with an initial velocity of 1 meter per second, and it takes 0.5 seconds to hit the ground. We're ignoring air resistance. Let's find the final velocity just before it hits the ground and the height it falls. We are given initial velocity equals 1 meter per second. Acceleration equals 9.81 meters per second squared. Time equals 0.5 seconds. We use the equations final velocity equals initial velocity plus g times time. Final velocity squared equals initial velocity squared plus 2 times g times height. After solving, we find the final velocity is about 5.9 meters per second. The ball falls a distance of about 1.7 meters. Now, let's try something a bit trickier, throwing a ball upward. Suppose a ball is thrown upward with an initial velocity of 1 meter per second. It takes 0.5 seconds to reach the ground. Again, we will ignore air resistance. We are asked to find the velocity just before the ball hits the ground and the total height it falls. This time, we choose upward as the positive direction, so initial velocity is positive 1 meter per second. Acceleration due to gravity is negative 9.81 meters per second squared. Time is 0.5 seconds. We use the same equations. Final velocity equals initial velocity plus acceleration times time. Final velocity squared equals initial velocity squared plus 2 times acceleration times height. After solving, we find that the final velocity is negative 3.9 meters per second. The negative sign means it's moving downward. The height fallen is about negative 0.72 meters. Again, the negative means downward displacement. This motion, throwing something upward, can also be shown on a velocity time graph. Let's keep upward as a positive direction. At first, the ball moves upward, but gravity slows it down until it stops for just a moment at the peak. That's where the velocity becomes zero. During that time, it rises about 0.005 meters. Then the ball falls back down, speeding up as it goes, and eventually hits the ground. It falls about 0.77 meters. So the total vertical displacement from start to finish is negative 0.72 meters, meaning downward overall. What's interesting here is that even though the direction of the velocity changes, the slope of the graph stays constant. That's because the acceleration of gravity stays the same and always acts downwards. Alright, let's wrap up what we learned today. 1. In free fall, the only force is gravity. The acceleration due to gravity is 9.81 meters per second squared, and it always acts vertically down near the Earth's surface. Freefall means we can ignore air resistance. 2. We can apply the equations of motion using g equals 9.81. That gives us all the equations we need for objects in freefall. 3. When solving problems, it's really important to choose a direction to be positive, then anything moving or pointing in the opposite direction is negative. That helps us keep the vector directions clear when using the equations. And that's it for today's lesson. Thanks for watching. I hope you now have a solid understanding of motion under gravity. Try using what you've learned to solve problems in your everyday life, whether you are dropping something or watching something fall, and you will become more comfortable with the physics of free fall. Thanks for watching again, and I will see you in the next video. I'm Physics Michael. Happy learning!